So yeah, welcome everybody. We've got 45 minutes. This is really a session for you guys, so please feel free to ask some questions. I'll get us kicked off. But yeah, we've got a great team in front of us. I'll come over here. The whole kind of pipeline or life cycle of machine learning, from getting data in to all the exciting like modeling and applications you can build, and then finally the model serving as well. So yeah, I'll grab a seat and we can just pass the mic around. Maybe get started with a question I certainly have, which is, what are some of the like interesting or maybe unexpected applications of ML that you've found recently? So maybe Harrison, if you've got anything on this, or also anybody else that wants to chime in, then feel free to go ahead. Yeah. Press 1.
Testing. All right. I mean, I think the most creative one that I've seen is related to the demo that we did with Patricio earlier, which is a dungeon master for running Dungeons and Dragons games. And I think that's interesting and creative, but at the same time not like unexpected when you think about it, because like, what does a dungeon master need to do? And this is like using Langchain, so obviously I'm biased, but like, what does the dungeon master need to do? One, like they need to be creative. So like that's really good for language models, because if language models aren't always perfect, but if they're not perfect in a dungeon master setting, that's kind of fine, because it's a creative, fun thing. 2, there's like a lot of like data that they need to connect to, right? There's the data of the background of the people, the background of the quest, and then as the quest goes on, you start to accumulate data. So you're connecting kind of like language models to other sources of data. And then 3, as a dungeon master, there's a lot of like reasoning that you need to do about what should happen next. What is the outcome if this person does this thing? What influences that? And so that kind of like marries a lot of the things that I think make really interesting LLM applications, which are customized data that you connect your LLM to. It's in a creative way, and it's using some reasoning logic.
Cool. I thought that was great. You want anybody else want to say anything?
I like it.
Yeah. No, we're good.
Yeah, I got one real quick. If this is working. Just once.
If it's green, it's good.
Check. Cool. Yeah. So pseudocode. Who's inherited code they haven't written? Yeah. So exactly. I really felt it was helpful to like plug it into plug pseudocode into ChatGPT. Someone gave me like a macro, an Excel macro I had never seen before. I was looking at it, I was like, this doesn't make any sense. What is going on here? So I said, ChatGPT, explain this to me like I'm 5 in pseudocode. Bam. Like, I don't know if that could ever be used to document people's, like comment people's code, for that guy or that girl that never commented anything and never does. But that I thought was really cool. And if I could apply this to more complex God classes and just be like, hey, can you break down sections of this for me? Like that would be really, really, really helpful.
I do have one as well. That came up a little bit as a surprise. So with Airbyte algorithms, we just build connectors. So pulling data from any kind of sources, very tedious, very hard worked there. And we keep building abstraction to make it simpler for developers, to make it simpler for our team and our community to do it. And we just recently released a way of declaratively creating connectors, and we also built a UI on top of it. And at some point, one of the engineer who was working on the UI just created a button saying like, automate creation of a connector with that documentation. And boom, it generated all the declarative file, pulling data from, I think it was a Freshdesk API, and we had a connector up and running in just a click of a button. So removing all the building phase, removing all the auditing of looking at the documentation and just getting, I won't say it was working 100%, it was working 90%, but it was already a very big help for the team to have that. So still an experiment, but coming soon.
Cool. So another one I'm certainly really interested to find out about is to do with data. So we've got Pieter here from MariaDB and Michel from Airbyte. Models are nothing without the data that they're built on. So getting really good data and at scale piped into those models for training is the core and fundamental part of training models. So what are some of the things in that kind of world that you're working on to enable that for developers?
Sure, yeah. I think a lot of people are dealing with huge amounts of data in their models, and those inferences that they make may spit out quite a bit too. So where you put that, how you put that, I think someone was asking a question just a second ago to you about, is this a general purpose distributed, or a general purpose database? And you were like, no, not quite. You'll want somewhere to house that data that is going to scale with you. Be it you're doing back-end distributed stuff and doing like database per service type of development, or whether you're working on some of the newer distributed SQL systems where you can kind of code like a monolith, but that there's a back-end data infrastructure sort of multiplexing out behind you and is going to give you the scale, give you the availability, give you the reliability, and yet not have to sacrifice standard ANSI SQL transactions and things that you know how to work with, or consistency, of course, right? So that's just one thing.
Yeah, and to add to that, you have all the storage, and the thing is, the data that comes into that storage comes from somewhere. So it can come from, I don't know, if you're a marketing team, it can come from your HubSpot application. If you're sales, it can come from your Salesforce application. And you have all these different data silos. And when the data is there, you cannot use it. You cannot feed it into any model. And getting that data into databases like Mongo and making it readily available with a stamp of correctness, and also with the ability to get the incremental update, because every company is a living organism, so data keeps coming up. This is something that becomes more and more important, especially as you start getting to do like live search on, I mean, you don't want your data to be stuck in 2021. You want your data to be stuck at a minute ago. And just having this pipeline that are live and that keep feeding new data to your model, that's a key piece there.
Thank you very much. Okay, maybe something on open source. A kind of tricky thing we've seen a lot more recently is the pros and cons of open source versus proprietary models. There we go, we got it. Yes, do any of you guys have any thoughts on the pros and cons of those?
Yeah, this is something that we've seen from like a ton of the enterprise users that we've talked to, because they come across like the toolkits out there these days, like Langchain, LlamaIndex, and then they come across like the set of models. Most enterprises, probably like 70%, are a little bit wary of sending data to OpenAI for some reason. And I think one of the default things they ask is just like, is there any sort of like PII masking, right? Like, can I like mask information? But then like, depending on how you do it, like no one's really explored this yet. You like basically throw out a ton of valuable information if you like try to do PII masking, right? And so therefore, I think in the past few months, there's been like an incredible rise of open source models out there, and everyone's like, fine tuning, Llama or using some technique or LoRa to basically create these like kind of more domain specific models. And I could see that is very much a path for adoption for these enterprises, because it's just a lot more comfortable for them to be able to like host a model on their like, on-prem server, as opposed to depending on an external API. And so it's interesting to see how that stack emerges and whether or not people, like the extent to which enterprises will be comfortable with using kind of like a third-party service, right?
Yeah, I mean, I think I totally agree with all that stuff. It's the main thing is definitely for enterprises is to make sure that your data is safe, right? I think another big thing is that a lot of these language models, the proprietary language models that you're sending your data off to, are a little bit more of a black box than just a language model, because they're more like language model systems, right? You don't really know what's going on there on top of the language model, and its stuff is difficult to reproduce, and you're always kind of at the will of whether or not that API is up or down. Yeah, so what I think is awesome is being able to actually have tensor level access to the language models, right? Being able to actually use the model and understand the model yourself is huge. Being able to fine tune the model on your specific data so that your model is your model, I think that's huge. And then also by having a model be open source, you have the ability to do open evaluations and actually be able to tell which model is the best. Yeah, one thing that we did the past few weeks at Hugging Face, there's a open language model leaderboard. So you can check that out. So like the top language models in the world that are open source. Yeah, I think it's something we're going to continue to watch. I think there's always going to be this battle between open source and proprietary, and proprietary is always going to have a significant amount more funding, but I think open source will, in the end, be best for, I think, all developers and enterprises. Yeah.
And what are some of the challenges of building open source software? Certainly, it's a space we're in right now, and yeah, trying to have a mix of doing something that's best for the community, but also we're a company trying to monetize as well. How have you guys found that dynamic?
Sure, I mean, I'll answer it. I think that the interesting part about releasing a model open source, I mean, it's a significant investment, right? Significant. But something that's really, really interesting about it, and then we've seen this a few times before. I think the most interesting example of it was with like Stability AI, when they helped release Stable Diffusion, is that when you release a large, very capable model open source, you effectively open up free R&D for your model. So this is one of the coolest parts to me, I think, is like, you know, they released this model and then immediately there was all these optimizations. I mean, Llama is one of those things, right? Like when that got released, there's significant optimizations that got released immediately. And the companies that release it then are like, okay, cool, thanks for all the R&D, and now we can go build that into a product or whatever, or not, right? I think it's best for it's really cool for the community. Now, it's always going to be difficult to release a model that is really significantly large for somebody that's not a gigantic corporation or like a nation state. But there is this sort of sweet spot, I think, that we're seeing where it makes sense as an investment as in order to gain things like R&D and also, you know, a name for yourself. Yeah.
Nice one. So with that, I think we can start to open up the floor to other questions. So as a quick refresher, I'll just remind everybody of names, especially for those watching on the TV. So we've got Jerry here from LlamaIndex. I'm Tom from MindsDB. I lead the engineering team here. We've got Michael from Airbyte, and Pieter from MariaDB, and Nate from Hugging Face, and Harrison from Langchain. So yeah, if you'd like to raise your hand if you have any questions, we can get someone to pass a mic around. And I think we've got one in the middle over here. I'm gonna steal the mic. Okay, there you go.
Hey guys, my name is Michael Cho. I'm curious whether you guys have come across any copyleft licenses, but for data sets. It seems to me that a lot of the licenses discussions have been around models. I'm just wondering if, you know, someone actually have a proprietary data sets that they want to share with the world, but how do they do that effectively? To make sure that whoever built on top of that, let's say if it's a model, like how does that translate? Yeah, thanks.
Interesting. I've certainly heard anecdotally of large corporations being very concerned about using other people's data sets and getting into really hot water for using other people's data sets, even if it's just in a very small part of the overall application. So yeah, that resonates with me. I don't have any detailed information that I can share about any of you guys.
Yeah, I mean, at Hugging Face, we have a wide variety of data sets that are licensed in many different ways. I think it's important to read the license. I think it's important to make sure you understand the license that you're looking at, so you know the implications of the downstream, your downstream use case, right? And this goes for models as well. I think the model inherits the license of the data, right? So yeah, it's something to be careful about. But yeah, we're seeing all sorts of different licenses right now. A lot of them have limitations on corporate use case, and that's usually to help you because this data has been probably scraped from the internet, and you want to make sure that you're not going to be held liable for anything, yeah, downstream.
I was just going to ask you a follow-up to that because I think you might have the best perspective. But yeah, like when do you see the different licenses coming into play, and like what are most of them? Yeah, like and in what situations would different people use different ones?
Sure. Yeah. So I think it all comes down to the data sources. So you know, if they've if they've gathered the data from certain public data sources, they're not going to be able to license it in that way. And this is especially true for very, very large data sets, because usually you're crawling the internet, and like you can't say one way or the other. That's what usually comes up, is people literally can't say, I don't know what the copyright of like the license of this is, right? So they end up going with more restrictive licenses in these cases, because they're like, I don't know, it's up to you. Yeah. But if the data's been like really curated well and really thoughtfully, then they're able to kind of open up the licenses a little bit more. That's what we've sort of been seeing. But yeah, it's definitely still quite a tricky thing, and I think it's something yeah, we continue to be very mindful about.
Do you ever see people like do that curation and then want to have more restrictive license on it, because you know they've spent all this time to gather it and there's some value there, right? Like,
yeah, sure, absolutely. I mean, I think this is the biggest one, right? I think there's tons of these data sets that we don't see, right? A lot of these don't come to, even to open source at that point or something. Or people will ask to take them down later, or like they'll be like, oh, never mind, we changed our mind, or yeah, you can't use this for anything. It's only for research. You have to accept our terms, and that's fine, right? They spent all this time curating that, and they spent a significant amount of money on it, to paying real humans to annotate the data. It is theirs to do that with. But these are usually the highest quality data sets, and I think a lot of key players, if you're smart right now, are sort of labeling your own data, taking the time to be really thoughtful about labeling your own data, so you can create fine-tune models that are really good for your use cases.
Slightly different context, but same dynamic, I think. MariaDB just launched a geospatial service, and we were talking about this exactly. We're like, okay, where are we going to get map data? You know, if somebody lands a plane on a runway that isn't there, like we could be liable, like, uh-oh. So how are we going to deal with this? And we went after, government, as you said, curated data sets. I think it was like a USDA data set. They make it publicly available, and they even like pay for the, Amazon as a program where they host some stuff on S3 for free. So yeah, my question back to the gentleman would be, what publicly available curated data sets are there available for you to work with, where it's provenance? And yeah, that's a really good point in terms of like highest common denominator restrictiveness. When you have no idea what's in the box, you can end up being much more restrictive. So yeah, if there's stuff on Kaggle, there's stuff elsewhere, government data sets, those might be great places to start. But more than likely, I guess you're probably going to end up making your own. Yeah. So what's in the box.
Or you can go to Hugging Face and try to compile a bunch of different data sets that have good licenses. But, yeah.
Okay, thank you very much. And any more questions? Yeah, we've got a gentleman in the front here. Okay, you can use mine. There you go.
What are your, my question is, there are a lot of data that's encapsulated in PowerPoints, PDF. Unfortunately, they went the other direction, right? People stop writing words, they use charts. What are the current state of the art in terms of interpreting charts and graphs, with or without numbers?
We have a pretty basic implementation of this, but I'm super open to contributions. Honestly, I think this is actually an area we're like actively exploring. If you look at a PDF, there's like a bunch of text, and there's like charts and also tables and just like a bunch of other stuff that you kind of have to like pull apart, right? And I think these days, like a very basic approach is you just run like an image captioning model, right, on the image itself, and then you like try to, assuming you have a good enough image captioning model, it will describe this in words or something like that, right? And if you wanted to, you could like try to, if you had a good parser, right, that could read like the content, you could extract the numbers and try to extract that into some like structured data point they then put into a table. Those are probably the two main approaches I've seen. That said, though, I don't think, I think there's like a ton more work to do in this space, and I actually am super interested in like trying to make this better, because if you look at how you feed data into an LLM these days, it's super basic, right? You like split up the text, right, and then you like just input this like raw text into the model. And then if you look at a lot of these hybrid documents that contain like charts, tables, one way is to extract that back into text that you can then feed into the model. But if you can somehow like have another representation of like any sort of image structure, or like even combine like structured and unstructured data in some sort of semi-structured format, I think that would be a promising like future direction. So I think there's like basic ways you can do that, but I think a lot of that, I'm actually curious to hear the audience's thoughts too, and you guys.
I think there's also like multimodal models that'll be coming that can handle some of this. And then, yeah, I think I think it's like a really hard, I mean, PDF extraction has been around for a while, but it's a really hard problem. I think there are, chatting with like companies that do this really well, they mostly have like internal algorithms for doing this because it's a bit hard. It can get kind of like domain specific. So maybe like the most general thing is kind of like a multimodal model that's coming soon.
Yeah, I suppose also outputting to chart as well. I suppose is that an area that you guys are looking at? It certainly seems potentially a little bit easier since you have like a data frame that you can define really well with the prompt, and then potentially with a tool on top of that, it seems a bit more potentially manageable. But. Okay, another question. Here we go. This man with the funky jacket.
Thank you. My name is Johannes, and I guess all of us are taking for granted today that World Wide Web is an open. You know, it's everybody for to put up their websites, earn money, conduct commerce, etc., etc. But in the 90s, it wasn't that obvious because there is corporate network, you know, pushed by Disney, Comcast, Microsoft, etc. And if you look, the next platform shift that happened, smartphone platform, which today is a closed one, is basic walled gardens. You know, we don't control the business model, we don't control the distribution. And so what we're also seeing at the moment, you know, Google's side, Microsoft's side, pushing their plugin platforms, and they control the distribution. Are we going to end up with this new AI platform, which might be one of the biggest platform shifts? Is it going to be an open one or a closed one? And how do we make sure it's more as in a World Wide Web compared to the previous App Store platform? Thank you.
Yeah, sure. I think it can go one of two ways. I think that's it'll be both. I think that there will be significant amount of this stuff open. I mean, it feels really biased to say this, but Hugging Face is that sort of that platform, the open platform for machine learning right now, where people are sharing these models and these data sets and these demos and things like that. Really didn't mean to plug there, but that that really is what we're seeing. So it's like folks are either going to use the proprietary you know, sources, or they're going to use these open sources. And I think that I think both will be built out significantly. I think that the closed ones will always be or like will always lean to be a little bit better or a lot better because of the funding and because of the nature of the business model. But I think that there's always going to be these hungry people that are building things in the open and trying to build them better, and they'll always be right on the heels of the closed ones. So yeah.
Just adding on top of that, I think there's a few different layers as well. There's the model layer, and then there's the whole ecosystem around it. Like if you look at plugins, that's not necessarily a model. That's the ecosystem or the agent or something like that. And so I think it's interesting to think about what will happen at both of those layers. And, you know, I don't claim to have an answer for any of that. I think you're also talking to a very biased group of people who would probably all want that to be in the open. So I don't know if you're going to get any true unbiased opinions here. But I think it's just interesting to keep that in mind and watch each of those separately as well, because I think there's different dynamics in terms of the players and what does it take and those things.
I think also a difference between what happened in the 90s and what's happening today is who is making the decision today. And when you're looking at technology and new technology in a market that is extremely new, the people that are in that room are the people making the decision. Whereas if you look at the 90s, every decision was made very top down, where you have a set of application and it's being pushed to the organization. Whereas here, everybody is working on, hey, this is the project I need to do. Either I build it myself or I'm going to find something online. I'm going to find open source software. And that's, for me, a big shift that just go in the direction of, it's going to be a mix because some people don't want to be taking open source software. They don't know if there is support. They don't know if there is any licensing problem. But the world today is being created with a lot of open source at the root for everything AI related. So it's more market and user shift there.
All right, we've got another question in the middle. That's you. On my way. Thank you, Eric.
Thank you for the time. This panel is awesome. It represents so much of what I love about our industry, right? It's all, you represent an entire tool chain, an open tool chain that's helping us build awesome things. And Jerry and Harrison, it's great to see you in person. I've followed your podcasts. Every time you do an interview, I'm kind of lurking and trying to glean some insight. So with this tool chain, what are the tools that are missing from your perspective? What would you like to see next in the open community?
Yeah, I mean, I think there's something for everything. I do think for me, I've always been obsessed with sort of the transition between different phases of the life cycle of machine learning. So like going from, as you're developing, being able to quickly iterate between, data gathering, data preparation, training, evaluation, inference, app, serving it to people, collecting information about that app. Getting as many eyes on it. I think every step that I just mentioned, there's transition phases in between that are quite time consuming, especially as a developer. And I think making that sort of faster is something that I'm still looking for. And maybe it's not possible, but it's something that for sure I've been thinking about a lot. And yeah, we've been trying to build tools around, but it's a difficult problem.
Yeah, I think like the definition of a tool is pretty general, right? There's like agent tools, there's like MLOps tools, there's just like general applications. But I think there's like a lot of areas in a lot of these different fields that probably need expansion. So for instance, like the MLOps tooling landscape, is pretty hot like a year or two ago. I think the same problems still apply. Like you still need like observability, tracing, evaluation. Like no one really knows how to evaluate LLMs in a scalable, reliable manner. Like how do you do that well? And so I think that's probably one area that needs fixing. I think there's also just like this whole world of like LLM enabled like tools, right, for agents that Harrison could probably speak to a little bit more. I think for me personally, another area that I'm very interested in is how LLMs can help like automate the kind of like data infra landscape. I think that's just a general category that I'm very interested in. So like if you have, just massive amounts of like unstructured data, how do you automate kind of like the extraction into like structured data? How do you like automate some steps of ETL? Does it like change the underlying like data stack, right? And I'm curious to hear like Airbyte's thoughts too. Like, I think this is something that we're very interested in just because like, if you think about like how long it takes to set up like a QA system over your data these days, right? With LlamaIndex and Langchain, it takes like 5 lines of code. But like, how do you just like generalize this idea and really just like transform the way like data is processed? That's just a hot take that I'm very interested in. Yeah.
Yeah, I mean, adding to both of that, I mean, I think both of them mentioned kind of like evaluation and that cycle in some way. I think that's really interesting. A bit more out there, one idea that I'm really interested in at the moment is like the idea of like long-term memory for some of these AI systems. Like everyone's talking about, okay, I'm going to make a personalized tutor for this student, but like, what does that actually mean? Like, how actually is it going to interact with them? And like, I think some of the papers around generative agents and reflection steps there are potentially really insightful for what could be missing there. But I think that's still really underexplored. And so I don't know exactly what the exact tools there are, but I think like pushing on that area is still extremely open.
Amazing. Okay, we've got another question. One right at the back, and then the next one, you go to or the other one. That's fine, baby.
Is this working? Cool.
Yep.
So I had a befuddling experience in 2015. I was working on Gmail, and part of my responsibility was spam and abuse. And we replaced the Gmail heuristic spam filter that had been evolved over the course of 10 years, and with tens of thousands of rules. We replaced it with a trained model, Ray Kurzweil's The Brain. And we ran them in parallel. And when the brain was doing better, we shifted over to that. Well, one of the things that we lost was the ability to say, why is this message in spam? Because it used to be we could say, well, rule number 527, rule number 6,347. And now we could say, because the thing said so. So I'm interested in knowing, are you seeing any new sort of emerging standards or practices around verifiability, attributability? Like, How do I know that this thing was not hallucinating, or give me some insight as the recipient of an answer from a learning model? How do I give me something to trust it?
I can take an initial stab at this. I mean, LLM hallucination is like a big issue that I think a lot of people are dealing with. To some extent, I mean, I think there are techniques for doing evaluation. My personal take is I don't think any of them are like completely solved yet. I think there's like a ton of work in progress. One thing that you could do, like that a lot of people are interested in with LLMs, is just like being able to cite sources, right? So like if you have some retrieval augmented model, you retrieve the sources, and then you can like, cite it in the response. So at least you can like backlink to the original data. That helps add like a layer of interpretability. The other part is one way you can like measure hallucination is you can like measure kind of like the consistency between the kind of like generated answer with the set of like retrieved sources that you get. And how do you do that? You can like feed it back into the LLM again, which, some people are less okay with, some people are more okay with. I personally don't have an issue with it. I think there's more just like some system and performance issues with that. But I think one thing about LLMs is that like, different than a supervised machine learning model, there's like interpretability works on like just like traditional machine learning. But with like generative models, you can actually have it generate stuff for you in like plain text and try to reason through it. And as long as you kind of like trust it as a reasoning engine, you can use it to like, do some evaluation decisions over your results.
So I don't know if there's this technology already, but one thing that is very important whenever you do data analytics or anything with regard to data is the lineage of that data. How did you come up with that particular table, that particular value in that field? And talking about what tools might be missing, what is missing today is how do you create attribution for the decision, which is tracking it down to what data fed into this particular answer. I know it's already an unsolved problem for data, so adding AI on top of it is going to be even harder. But this is something that will give us the certainty that it has been using this particular type of data, and this is why this decision was made, and tracking it down to the source of this is how I was trained. But yeah, there is a lot of aggregation happening, so probably an unsolved problem.
I've seen some traditional tools like Apache NiFi and stuff do a good job of data provenance, but I've never seen it in an AI context. And I don't know if that's like a generational shift, in technology or whatever, but I've seen some other like ETL, CDC kinds of solutions provide that. I don't know if anyone else here in the room has seen that as well, but it's not common. Yeah.
I mean, I think it's just harder. Even for traditional ML, I'm assuming like you can use like SHAP values or something like that. But those aren't perfect. Those aren't great. And now these things are even more hard to do with that. And I don't think there's to understand like why it's really actually making the decision. It's definitely not as concrete as like there's a rule here or there's a rule here. And that makes it really hard for some scenarios, especially around like hiring and stuff like that, where there are regulatory concerns and you do have to be able to explain these things. And there's not really great answers. And I definitely don't have any great answers here. And so I'm going to stop talking, but it's a hard problem.
Yeah, I'll just add one more thing. I think in industry, it's a lot more difficult. I mean, you can, just because you have this hammer of large language models doesn't necessarily mean that you have to treat everything like a nail. I think that there's a lot of space for still just using traditional machine learning or, these smaller models to solve problems like that. When I worked in industry, I used to have to build interpretable models for this very reason. I think if you were able to take these thousands of rules and group them into a smaller amount of, sort of grouped rules, and then use that as sort of a supervised, like use that giant data set you probably had to train a supervised model, then you're probably going to have a lot more explainability than a large language model. Because a large language model might generate, nonsense as an explanation. It might work 99.9% of the time. Then the one time it's nonsense, like, and you serve that to a user or something, then it could be bad, right? Yeah.
Maybe a question for you guys is just like, and I'm curious to hear your thoughts, is like when should we use like a large language model versus like a supervised model, right? Like if you already have a spam detector, when should you use that? And there's like trade-offs for each. And I feel like there's probably certain UXs that make more sense for using a large language model given their performance and generative capabilities, but also like speed and cost trade-offs.
we did a quick, I'll just jump in here for a second, sorry. But we did a study on explainable AI a little while ago, it was a couple of years ago, which was actually really telling. And so things like Shapley values and others weren't that effective. The thing we found the most effective in communicating what the model was doing was like counterfactuals. So you change the data, and you find that threshold when it makes a different decision. Like the answer would be yes, and you find that, and then and that explainability was actually really powerful. Now, the feedback from users was the most convincing. Even for people who weren't experts in the model, that was the one that they trusted the most, from just a user perspective.
Adding in another dynamic here, there was some Stanford paper that Jerry, I think you guys incorporated, that used language model. It was around, I think, extraction of structured information. And it used language models to like write code to do that extraction. And I think that one had the benefit of actually speeding things up, because you didn't have to run a language model over every document. You could run it over a few, generate some code that's generalized, and then run that. But then two, that's extremely explainable. Like the code is like, code and regexes, and you can see what's going on. And so maybe there's some like, parallels here for like, if you do need to like, it starts to get into code generation, which is a whole nother thing, but just adding that as kind of like another viewpoint here.
Yeah, for me, it's the two main components are performance and explainability. And I think it's fair to say a model that has been specifically trained with a particular task in mind, especially if it's something supervised, then the upper bound there for performance is typically higher than a completely general model. So yeah, like just testing and iterating is something we certainly do all the time. And depending on the use case, the explainability factor really weights highly or sometimes weights not so much. But okay, I think we definitely have two upcoming questions. One gentleman over there that has had his hand up for a while, and then we'll go over to our leader, Jorge, after.
Hello. Yeah, I saw the demos, very, very nice demos. Like we nowadays see that every week almost there's a new model outperforming open source, closed source. Also, we saw the demos, very nice. Both MindsDB has an amazing interface of using a model. The Gradio model also amazing to get it. But one thing that a lot of companies that want to build application will struggle is, okay, what are the properties of a model that I need to use to get a very good application that can scale? So always it's a multi-objective problem. Do I need explainability? Do I need the reliability and scalability, or do I need the data? So in this case, is it becoming an infrastructure problem, the LLM usage? So if I use MindsDB, if I know that I will use the OpenAI API and I have reliability that I know that always will work, then I will not bother of having my Gradio model, getting the GPU, updating it. So is it now becoming an infrastructure problem, a scalability for wider usage? Because the nature of those models are very, very slow. So to scale, you already have to pay a lot of money. So yeah, I wanted your opinion on how companies will deal with infrastructure of such models.
Right. I think it's really just about the nature of your team and where your company's at. If your company's comfortable with or your team is comfortable with building out infrastructure for hosting large language models and serving them yourself internally so that you don't have to send off your data to an API, then by all means do it. If you're not comfortable with that at all, or you're a small company and you don't have the ability to build out infrastructure like that, then I think APIs are probably the way to go. Somebody else have something to say?
Yeah, I totally agree.
I think also that's the reason why open source is so popular in AI is that nobody knows. And what you want is you want to keep the flexibility for the future to see, is there an actor that's going to be dominating good practices, or is it good practices that are going to come from people using it? And today people are keeping the choice. They don't want to go through one vendor, engage with one vendor, and be outdated because there is another one. And that's basically assembling building blocks and seeing how do I make my overall building better.
I think one last comment to add in addition to all these is just I think ML has always been kind of like a data problem, like even traditional machine learning. And so if you listen to like Shreya Shankar's like tweets, it's always just like ML ops is always just like data, right? It's really not about like training the model. It's really just about like how do you get the data and productionize it and you know, take into account all the different factors like speed, latency, cost, performance, all these different things. And I think it's the same with LLMs. Like I think these days, like everybody's faced with like a plethora of different choices. You have like open source models, you have like you know, OpenAI. OpenAI takes like 3 seconds for the generate completion, right? Does that make sense for your kind of like use case? Does your like use case need to be real time? You know, do you need to support like streaming? Like how many queries are hitting your endpoint, like, you know, every second, right? And if like it's going to take seconds, like it's probably not going to make sense for the user. So I think these are all considerations. I think there will probably be like kind of more best practices emerging around like different types of models for different types of like end user UXs. But I think it's very much like a combination of just like the ML performance, but like wrapped in this entire like systems problem of like, you know, everything else.
Yeah, I think just to add to that, with large models, language or otherwise, it's a very cost prohibitive problem, like running large GPUs. And if you're doing the things at scale, then with multiple of these in parallel, you're going to be racking up some pretty big bills very early. If you're a small company, that's just almost a non-starter, or at least you're going to have to get funded very quickly. So I can totally see the value of having this as like a managed service, at least in the early stages, and having somebody else take care of the infrastructure side of things, I would say. Okay, should we move over to Jorge?
Yeah, I think we got time for one more. I can't remember who was in line here.
Yep.
Maybe 2 more.
So for explainability, have you guys run across using adversarial transformers? Because you could, I mean, in theory, you could have a system that is generating explanations, and many of them will be hallucinations, but you could have another system that will try to, you know, determine if they're hallucinations or not. And one will get really good at discriminating them, and the other one will get really good at building explanations. And if no one is doing this, we should probably sit down and do that because.
So I think one thing that's related to that, and I think that's probably doable when you can like train the underlying models themselves. One thing that's related to that I think this came out a few days ago, is basically to evaluate whether a statement is correct, you can actually have 2 language models argue whether it's correct. And you tell one to like argue that it is correct, and you tell one to argue that it's not correct. And then that actually, I think they did like a study empirically, and it like for humans, it's much easier to tell looking at the argument which side is correct rather than just looking at just the statement itself. And so it's just a way to improve. It's not exactly explainability, but it's a clever idea to like make it more easy to understand the correctness or not.
Pretty cool. Oh, sorry. This is honestly not that helpful, but I used to do a bunch of research in GANs, and so I'm just very interested in this. So if you guys aren't familiar with GANs, they're basically what Jorge was describing, but like with images, and you know, they were all the rage like 5 years ago. And so if you guys want to train that and try it out and see, you know, the problem with GANs is they were like super unstable. Like it was just really hard to train for like a lot of different things. But if you guys want to try that for a natural language, I'm very curious.
Let's do it. Sounds good. Okay, sounds like we've got time for
one more
question. Pressure's on.
Right now, developers are really excited to connect LLMs with a lot of APIs without really thinking about security, privacy. What are your thoughts on ensuring that the API or LLM stays in its lane and doesn't compromise, misuse the API?
Yeah, I mean, I think this is, there's a lot of talk about AI safety, and I think like focusing on the models is definitely important, but it's also really important to focus on the systems that do have access to these types of APIs, because I think that's when things can really start to go off the rails. I think like one thing is basically, you know, permissioning of whatever you're giving the LLM access to. So if you're giving it access to a Python REPL, maybe don't give it access to a Python REPL where it can destroy your Kubernetes cluster or something like that. And I think and OpenAI has their like code interpreter thing, and they have their sandbox environment just for that. Very different from the Langchain Python REPL, which just uses your local thing and is extremely unsafe, and you should not be running in production, right? So I think part of it is just giving it access to the right tools. There's also another aspect that you can, that doesn't solve everything. So if you have like an agent that has access to an API to like delete emails, that could be good because it's like a personal assistant agent and you might want it to delete emails. But if it just goes rogue and deletes every single email, that's obviously bad. And so how do you safeguard against that? I think there's like some ideas around, it's an unsolved problem. I think we did a webinar on prompt injection, which gets related to this. And I think the biggest takeaway was that there just needs to be more discussion about this and more awareness that this is a problem so that you don't have people giving LLMs access unfettered to dangerous APIs. And so I think just like even asking this question and having some discussion is the best thing. But yeah, there's like some approaches around like using some type of like detection on the inputs to like see if it's malicious or not. But then it gets into like a game of like cat and mouse, kind of similar to like cybersecurity. So those are my general thoughts.
Yeah, I don't know what you call this, but I mean, I feel like, yeah, I love your example of, oh, I have access to an API that could destroy my Kubernetes cluster. I feel like there's a moment where the language model should prompt you like, are you sure? Yes, no, you know what I mean? And you should be able to give it some feedback. You trotted out a term a second ago that I think might have been that. What was that called?
I did.
Oh, okay. Maybe not.
Well, I think that's adding in these safeguards around tools and part of this being like, yeah, human in the loop, yes, no.
Exactly.
Yeah, that's a very good thing that I forgot to mention. That yeah, I think that's really important.
And what you said, I mean, like, don't bring an API to the model that could maybe do something, but that seems like a sort of unsophisticated way. You might want it to delete your emails. You know what I mean? Like, please empty my spam folder. Would be great, but
we don't have this in Langchain, but I'm going to go at it right now. Is for every tool you should be able to say like needs human confirmation or not. Like that should be built into like these types of systems because that's
destructive operations. Yeah.
Cool. Ooh, okay.
Oh, the other thing I was just going to say, which was related to your guys' points, is I think I feel like reads are more acceptable than like writes, right? So if you like load in data, it's like way easier to not have human in the loop than if you were going to delete an email or like insert something. And so maybe that's something that you could add. It's just like human confirmation for kind of like more sensitive API calls. You do that.
Awesome. I think that's all we've got time for. We've got some lunch up next, back at 12:30 for Michael. But in the meantime, I'd like to invite you all to give them a quick round of applause. Thank you.